How are you, my friends? This is lecture number 15 of the Calculus 1 lectures about increments, differentials, and linear approximation. Please study this one carefully because there are so important definitions in this lecture. So the objectives of this lecture will be the increments in values, the differentials and linear approximation to the function f of x near the point x equals a. And we'll look at some differentials. Now let's define increment. There is an increment delta x and there is an increment delta y. Increment is an amount increased to x. So x, it will go to x plus delta x. So here suppose we have x. If we add an increment delta x, it will be x plus delta x. Delta x is a very small number. Maybe x is 2 and delta x is 0.1 or 0.03, whatever. So if we have the point here, the value x, this point on the curve, it will be f of x. So we replace x in the function. This is the graph of the function. Now, if we have the other point, x plus delta x, if we replace it in the function, we get f of x plus delta x. Okay, now the increment delta y is the change in the value of y along the curve. So from this point, which is x f of x, to this point, the y change here is delta y. So we can write delta y, you can see it from the graph, so clear, delta y. It will be all this minus this one here, you see? So delta y we can write, this is equation star. It will be f of x plus delta x minus f of x, whatever the value for x. So remember this star equation. Again, delta y will be f of x plus delta x minus f of x. Let's call this equation star. We will use it later. Now this is introduction to differentials. We know the derivative formula is f prime of x is the limit of this difference quotient, f of x plus h minus f of x divided by h as h goes to 0. Let's put this h as delta x. It's a small increment delta x. So we will have f prime is equal to the limit of this one, f of x plus delta x minus f of x divided by delta x as delta x goes to 0. Now we know this one here is delta y. We have seen. So this is the limit of delta y over delta x as delta x goes to 0. Okay, that will be a constant. So f prime of x will be approximately delta y over delta x. So if you cross multiply here, what do you get? Delta y is equal f prime of x times delta x. Now let me explain secant and tangent. The blue one here is the curve. This is the graph of the function. The red one is the tangent line. Tangent line at the point x and y. You see? Now when we say secant, it's a line passing through 2 points on the curve. So this point here, x and y, and this point here, x plus delta x, and the y value is y plus delta y, or f of x plus delta x. So if the secant is approximately the same as the tangent, if this delta x will be approximately 0. So as you decrease this delta x to 0, this secant line will coincide with this tangent line. So now let's give this one f prime of x times delta x, this value here, let's give it a special name. We'll call it a differential. Differential dy is equal f prime of the x times delta x. Remember, if the secant line is approximately reaching the tangent line, so it will be almost the same. If delta x is very small. Now, let me here summarize the differential dx and the differential dy. The differential dx is the same as dx. And the differential dy is defined as f prime of x times delta x, or f prime of x times dx. Now, again, I will explain here dy and delta y, the difference between them. Dy is the change in the height of a point that moves along the tangent line. So when you have dy over dx, this will be the slope of the tangent line, this blue one. Delta y is the change of the height of a point that moves along the graph of the function. So this is on the secant. So slope of this secant line will be delta y over delta x. Okay. Now, linear approximation, the aim here is to approximate function value or the image of f of x plus delta x. So if we have a number here, x plus delta x, we'll see an example in a few minutes. If we have an x plus delta x, we need to approximate the function value, f of that number. Maybe this number, let's say 2.103. So we need to find f of that number. So it's better to use the point x plus delta x and the y value y plus dy. This is on the tangent line. See the tangent line here. It is better than the point x plus delta x, y plus delta y, which is on the graph here. It's easier to approximate using the tangent line. Now, dy is called the linear approximation of the increment delta y. dy is called the linear approximation of the increment delta y. So we can write dy is approximately delta y. Do you remember the equation, star equation we have seen maybe first or second slide? Delta y, it was, see from here also you can see it, f of x plus delta x minus f of x. Let's take f of x on the other side. So we get f of x plus delta x, which we need here. See, this is the function value of this number x plus delta x. So if you move f of x on the other side, we will have an equation, f of x plus delta x is equal, take it on the other side, it will be f of x plus delta y. See, this is on the curve, on this blue curve. If you replace delta y approximately by dy, it will be on the tangent line. So the linear approximation formula is f of x plus delta x will be approximately the function value of at x, because we will know also x, plus f prime, you know this formula dy will be f prime of x times delta x. Let me explain more about delta x. This is the graph we have seen before. From x, we go to the second point, x plus delta x. As I mentioned, delta x is a very small number. So this might be like 2, this is 2.03, whatever. Let me write it in another way, this increment delta x, to make it easier. So I can write a is the number here, you see, a plus h. So h will be the increment here, because if you take a plus h minus the a, see if you take here x plus delta x minus the x, you will get delta x. Look here, a, it will go to a plus h, so we add an increment here. So a plus h minus the a becomes h, so this is also delta x. So we can have a number and then another number added to h. Or we can write a, and then here is the x. So a is a number, and x is the number added with the increment. So if you write now x minus a, it will be delta x. That is the form we will use, which is easy. So a is a number, X is the number added with the increment. So delta X will be X minus the A. Now be careful. Let's see here. So this is what we are going to use. We have seen the linear approximation formula, f of x plus delta x, f of x plus f prime of x times delta x. So if we replace now x with a in the above equation, so we put a here instead of the x. So we will get f of a plus delta x, approximately f of a plus f prime of a times delta x. So what is delta x? You see, x minus a. See, delta x now, we can write it as x minus a. This is f prime of a. This is f of a. What is a plus delta x? You see here, a plus delta x. Take a on the other side here also. So it becomes x. So this is the final version here. This is the final version. This is the gift here, the linear approximation formula at x. So we have f of x. So x is a number given. F of x will be approximated by f of a plus f prime of a times x minus a. This is what we have to remember. We will see nice example or more than one, I think right now. Yes. So remember the formula, please. You can write it down. F of x approximately f of a plus f prime of a times x minus a in the bracket. Now let's look at this example, please concentrate. If you write the question short, you can write it here, down here. Approximate cube root of 122 squared. Now here we need to approximate 122 to the power 2 over 3. So let's try to consider or construct a function similar to that. So we say f of x is equal x to the power 2 over 3. Now we have to choose a number a very close to 122 so that the image is easy to find. So let's choose a 125. So the image of a 125, we replace it in the function 125 to the power 2 over 3. We make it 5 cubed to the power 1/3 to the power 2. This is 2 over 3. So we can cancel the 3 here. So we get 5 squared is equal to 25. So the image of 125 is 25. We need also the derivative of this function. So directly here on the right side, we can find f prime of x. Using the power rule, bring 2 over 3 down, x to the power 2 over 3 minus 1. So it will be x to the power minus 1 over 3. So we can write it as 2 over 3 times cube root of x. Now, at x equals 122, the linear approximation is f of x, the formula, approximately f of a plus f prime of a times x minus a. Now, f of x, which is f of 122, will be f of 125 we have found. It's 25 plus f prime of 125, replace 125 in the f prime. It will be 2 over 3 cube root of 125 times x minus a. So 122 minus 125. You can simplify that easily. This is 5 here. 122 minus 125 is minus 3, so you can cancel the 3. So you have 25 minus 2 over 5, which will be fraction 123 over 5, which is equal to 24.6, or you can leave it as a fraction. So now what do we need? The conclusion, the estimate for 122 to the power 2 over 3 will be approximately 24.6. Now, linear approximation to a function near the point x equals a. This is really nice. So we have a function here. See this blue f of x, it has a graph there. And we need to approximate this function. Whatever this function is complicated, we can approximate it by a linear function near a. So we know the linear approximation formula, it was f of x at a point x, approximately f of a plus f prime of a times x minus a. Let's find the tangent line here. Use this formula for the tangent line, y minus y1 is equal m times x minus x1. At this point, x1, y1 at a, f of a. So this is the point here. So I can replace, instead of x sub 1 here, is a, y sub 1 is f of a. Then I can find y. So y will be f of a plus, the m is the derivative here, f prime at a times x minus a. L of x is the linear approximation to the function itself near the point x equals a. So L of x will be approximately f of a plus f prime of a times x minus a. Now remember, this is a function, linear function, and this is the value for approximating x. Let's see a nice example here. Find the linear approximation to the function square root of 1 plus x. This is not a linear function here, but we can find a linear function which is approximated to this function near the point a equals 0. So what can we do? This is the function square root of 1 plus x. Let's find the derivative f prime of x, 1 over 2 square root of 1 plus x. Find the image of 0, f of 0, put 0 in the function here, it will be 1. So the linear approximation will be L of x, that's a function, approximately f of 0 plus f prime of 0 times x minus 0. So f of 0 will be 1 plus f prime, put 0 there, it will be 1 over 2 square root of 1 plus 0, x minus 0. So the linear function, 1 plus half x, see that's a straight line. That will be the tangent line to this graph close to the point 0. That's a linear approximation. Now, example 3, use linear approximation to estimate sine 61 degrees. See, this is not an easy angle. We need a calculator to do it, but we can find a linear approximation to estimate sine 61 degrees. So let's consider the function now. F of x is sine x. Choose a pi over 3. Pi over 3 is 60, very close to 61 degrees, but we have to choose here radians. So let's find f of pi over 3 will be sine pi over 3, square root of 3 over 2. Now let's find the derivative of this function f. F prime of x will be sine of x derivative, which is cosine of the x. Now, this is the linear approximation. Remember, L of x will be f of a plus f prime of a times x minus a. So let's put now for a pi over 3. So f of pi over 3 plus f prime of pi over 3, x minus pi over 3. Now x is 61 degrees. We have to convert it to radians. That's a little trick here. So 61 times pi over 180. Now sine pi over 3 will be square root of 3 over 2. Cosine pi over 3 will be half times, when you add here the LCD, multiply here up and down by 60, it will be pi over 180. So now you can leave it like this, or you can use a calculator. This is 0.866 and this is 0.0087. So the approximated value for sine 61 will be 0.8747. Now there's a surprise here. Look at example 4. This is example 3 exactly, but in exam type. Use linear approximation to write the estimate of sine 61 degrees as square root of 3 over a plus pi over b. Then find the value a times b. So this is exactly example number 3. You see this one here? Estimate sine 61 degrees, but we can make it as an exam type. Write the estimate value for sine 61 degrees, square root of 3 over a plus pi over b. You will get these numbers, then take and b multiply them. So just take the values from the example 3 solution, L of 61 degrees, you get this answer, square root of 3 over 2 plus pi over 360. Now compare it to what's given in the question, square root of 3 over a, so a is 2 now, plus pi over b, b is 360. Find ab, 2 times 360, which is 720 is the answer. Example 5, we have 3 functions given here, y, function u, function w. Let's find dy, the differential dy of this function, find du, find dw. So it's easy to do that. Dy will be, find the derivative of this times dx. Because when you find dy over dx will be y prime. So this will be 6x minus 2, bring down 3 over 2, cancel the 2, 3 over 2 minus 1. So it becomes 6x minus 3 square root of x. You can try it, times dx. Now look at this one. U is sine squared of t minus cosine of 2t. Find du. So find the derivative of this one. Bring 2 down, 2 sine of t, 2 minus 1, times the derivative of the sine of t will be cosine of t. Here we have plus. Why we have plus? Because there's a minus there, and cosine of 2t, we have to use the chain rule. It will be minus sine 2t times the derivative of the inside, which is derivative of 2t is 2. Now 2 sine t cosine t, this is sine 2t. You see by the formula sine 2t, and there is 2 sine 2t. So the final answer will be du is equal to 3 sine 2t times dt. Now look at this function here, wz times e to the power z. Let's find dw. dw will be by the product here, product rule, z times e to the z. Just apply u prime v plus v prime u. You will get all this. You can take e to the power z as a common factor. So dw will be z plus 1 all times e to the power z dz. Now please always check the playlist Calculus 1 solved questions to learn more about the lectures. This is the end of lecture 15. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.